Welcome back to the Python for Beginners series. This series is intended for beginners who have never encountered the language and want to learn everything from scratch. In this part, we'll explain working with Python's basic data objects and explore the functions for working with these objects. I will show the examples in the Jupyter environment. I have also prepared several notebooks for the demonstration. I leave it up to you whether you also open Jupyter and try the examples right away, or whether you study only by watching the video. If you are going to try the examples right away, open a terminal and type Jupyter Notebook command. So, here we go. Before we start learning, it would be good to say a few sentences about Python syntax. But it could happen that the explanation would take too long and be boring. That's why I've decided that as soon as we run into any questions related to syntax and code notation, I'll explain them along the way. Since I will be using comments in the following examples, we will explain what comments look like and how they can be used. Comments are for one thing only. They allow the programmer to write down thoughts, reminders, or other things in the program. The language interpreter ignores all comments, so they really only serve our needs and won't affect the program in any way. I have prepared a sample of several possible comment entries. In general, once a hash character appears in a program, everything after it, up to the end of the line, is a comment. We can write a comment right after the command to note what the command does or why. We might as well comment out some piece of code that we don't want to be executed. Maybe because we're fixing a feature, but we don't want to delete the original code just yet in case we want to go back to it. Comments can be of any length. Only one rule applies. There must be a hash character at the beginning of each line. However, there is one more rule. Comments should not be stupid. There is no point in noting that a number is a number. While we're writing comments, let's make sure they're helpful. The last example of a comment is the so-called documentation string. Primarily used for purposes other than notes, but can be used if needed. Python will not throw an error. Documentation string always starts and ends with 3 quotation marks, and everything between these characters is considered to be the content of this string, regardless of the number of lines. We will talk about documentation strings later, in connection with functions and classes. Let's go back to our first program in the Jupyter environment. The program printed the text "Hello World" and exited. But what to do if we want to modify the text somehow, or change it while the program is running? Variables serve such purposes. Let's try to create one variable. Let's call it text1 and insert the sentence "Hello World" into it. We will then print the variable with the same command, but as you can see, we will not enclose it in quotation marks. The result is the same. What happened? In the first line, we created an instance of the data object and put a value in it. In order to work with the object, we created a variable to which we assigned the object. This mechanism can be a bit confusing at first, but it will make perfect sense after a while. There is one thing to be understood at the outset. In Python, everything is an object. Unlike other programming languages, Python follows this rule without exception. We are currently focusing on data objects. So what exactly is an object? Imagine a box in the real world, for example. A box is an object. The box has some attributes. For example, material, color, width, or height. The box also has its own methods. We can open the box, close it, put something in it, or even empty the entire contents of the box. We can also see what's inside at any time. Whenever we need a box to store our things in, we tell Python to make such a box for us, and we can then store our things in it. The box can also contain other objects. For example, written paper, a pencil, or another box. It is only up to us what we put in the box. In Python, every object is also such a box. This box is stored in the computer's memory, and we can see what's inside at any time. We can even change some attributes of the box, and of course we can also run the methods of the box. But what if there are more such boxes? In order to look at the contents of a particular box, we need to name them. Then we can ask, "Hey Python, what's in box 2?" And Python replies, "There's a pencil in box 2." Whenever we need to store data in memory, Python will gladly provide us with a box. But just like in the real world, there are several types of boxes. Each box is suitable for storing different things. We had a paper box in which we can store, for example, paper or a pencil. But what if we need to put a fish in the box? At that point, the paper box is useless. We will still need a box, but it will be more convenient if it is, for example, plastic, and of course there must be water in it. We can put a fish or even an octopus in such a box, but we cannot put a cat in it, because it would drown. It is the same with data objects. In some boxes we can store only numbers, in others only text. Let's go back to our program. On the first line, we told Python, "Give me an empty box, I want to store some text in it." In order to find the box in the computer's memory, we named it. On the second line we said, "Python, see what text is stored in the box and print it." Let's take a look at the most used data objects that Python provides. For now, we will explain only the most basic ones. As soon as we understand how they work, we will start with more complex ones. We will create 3 string objects and 3 variables in which a reference to them is stored. As you can see, we don't have to declare the string object in any way, as it is necessary in some other languages. All you have to do is assign a text value enclosed in quotes to the variable. Python is even benevolent in that we can use quotes or apostrophes. But there must be the same leading character at the beginning of the text as at the end. If we are not sure about the type of an object, Python provides us with a built-in function that returns the type of the object. As you can see, the function call returned str, which means a string object. How can we work with string objects? The first option is to use the object in an expression. In short, this means that we get its value from the object and use it for the calculation. We can then save the result in another object, or use it directly when the program is running. Let's explain a few terms that we will use often. These are some simple expressions that we have come across before. Commonly used expressions have 2 operands and 1 operator. If we use such an expression in Python, the interpreter looks for its operands, performs the required operation and uses the received result. On the first line is the assignment operator. Writing such an expression causes the variable text1 to be assigned a string object that contains the text hello world. The second expression contains an addition operator. The result of such an operation will be the merging of both operands. But there can be several operators in one expression. In this case, the expression is always evaluated from the end, that is, from right to left. So in this case, the 2 numbers are first added together and the resulting value is finally assigned to the number variable. As in mathematics, multiplication and division take precedence over addition and subtraction. In this case, it is evaluated from the end, but since multiplication takes precedence, the multiple is calculated first and only then is the number 5 added. If we needed to change the default order of evaluation, we have to enclose part of the expression in parentheses, just like in mathematics. We explained what expressions are and how we can use them. We also showed what is an operator. There are only a few basic operators for string data objects and they are easy to understand. Let's first explain the arithmetic operators. Although we cannot calculate with string objects in the sense of mathematical calculations, Python introduces 2 operators. The first operator is the addition operator. It is marked with a plus sign and causes 2 strings to be merged into one result. Remember that both operands must be of string type, otherwise an error will occur. The second arithmetic operator is multiplication. Unlike the previous operator, one operand must be of string type and the second operand must be a positive integer. This operator causes it to repeat the contents of the string as many times as the second operand. Python doesn't care which operand comes first and which comes second. We've already met the assignment operator. It is denoted by an equal sign and causes the object on the left side to be assigned the expression from the right side. For ease of writing, Python also introduces special assignment operators. Note that they begin with an arithmetic operator followed by equal sign. The effect is the same as if we wrote the expression like this. If we need to test whether a string contains some other string, we can use the logical operators in and not in. In both examples, the result is a Boolean object, which we'll explain in a moment. The result always returns true or false, depending on how the assertion is evaluated. Let's try the operators in practice. The first operator is the addition operator, represented by a plus sign. Once we use it, Python concatenates the two operands and creates a new object to put the result into. In this example, we are not storing the object in any variable, so the interpreter will directly use and print it. In the second example, we merge the two operands and store the result in a variable named text4. Then we can print it. As you can see, the data type of the newly created data object is string. The second operator is the multiplication operator. This operator requires one operand to be a positive integer and the other operand to be a string. Once the expression is evaluated, the interpreter returns a string repeated as many times as the numeric operand specifies. As you can see, the order of the operands does not matter. The second way to work with string objects is to use built-in functions. Python offers many of them, but in order not to get confused, we will introduce them one by one as soon as we need them. At this point, we will show three simple functions, just to demonstrate how to work with built-in functions. The len function returns the length of the content of the data object. It is a universal function that is applicable to most data objects and structures. If we use it on the string type, the function returns the number of characters that the string consists of. The max function is also a universal function that is applicable to most data objects. For a string object, the function returns the highest character contained in the string. The order of characters is determined by the alphabet. The last function we will show is, for example, the id function. Again, this is a function that is applicable to all data objects. This function returns a numeric value that represents the identifier of the data object. This identifier is unique for each object stored in memory. A very useful tool if we only need to get part of a string is slicing. Let's first look at the anatomy of the string object. A string is basically a sequence of individual characters in a row. The string object remembers not only each contained character, but also its order. The first character from this set has sequence number 0, and each subsequent character is always one number higher. This number is called the index. In addition to standard indexing from the beginning of the string, Python also uses negative indexing from the end. The last character then has the number -1, and each preceding character is always one number lower. The index allows us to very efficiently select only a certain part of the string. What if we want to find the character that is in the third position? We simply write the name of the variable and in square brackets the index of the third character, that is, the number 2. We will proceed in the same way if we want to find the third character from the end. Only in this case will we use a negative index. But Python can also return part of a string. Just write the number of the starting index and the number of the ending index, separated by a colon character. If we omit the first argument, the interpreter evaluates it so that we want to select everything from the beginning of the string to the end index. Conversely, if we omit the second argument, the interpreter returns everything from the starting index to the end of the string. To make things not so simple, there is a third argument that specifies the selection step. So if we write the following expression, the interpreter will return every second character from the beginning to the end. Arguments can of course be combined arbitrarily. Let's try some examples. Let's select the string from the 5th to the 12th position, or every second character. Be sure to try a few examples of your own. Slicing is very important in Python and you will use it often when writing programs. I said that string is an object. And like every object, it has its methods. A method is basically a function that is part of an object and can be called at any time. We call the method of the object by writing a variable that refers to the object, a dot, and the name of the method. Since this is a function, parentheses will follow and we can write any parameters inside if the method requires it. It is important to note that the method does not manipulate the object in any way. The content of the object does not change. If we call any method from the following examples, we get the result, but the object remains the same. As with built-in functions, we won't explore all of the object's methods right away. Let's look at just a few of the most interesting methods. The find method is very useful and you will definitely use it many times in your programming. Any string that we want to find in the text1 object is passed to it as a parameter. If such a string is found, the interpreter returns the position at which it is located. If the string is not found, the interpreter returns a value of -1. The count method returns the number of occurrences of the string in the object. If the string is not found, the method returns the number 0. The following two methods return a string converted to lowercase or uppercase. The last introduced method, which is also applied when writing programs, is the replacement method. Two arguments need to be passed to it: what string we are looking for in the object and what we want to replace it with. As you can see, the interpreter returned the replaced text. The next most used data objects are numbers. Python, like most other languages, distinguishes between integer and decimal numbers and introduces integer and float data types for them. A complex number is also a special type of number, but we will not deal with that. Working with both types of numbers is similar. Python recognizes the type of a number based on whether we write a decimal point when entering it. The same applies to computational operations. If the result is a number without a decimal part, Python treats it as an integer, otherwise it's a float. The set of operators for numbers is much wider than we introduced for string objects. Let's show them and explain them. Arithmetic operators are intended for working with numeric objects in Python. In addition to the standard addition, subtraction, multiplication, and division operators, which are written with the same symbols as in other languages, Python uses the exponentiation operator, as well as the modulus and floor division operators. The floor division operator is written with 2/ characters. After its evaluation, the first operand is basically divided by the second, but the language interpreter returns as a result only a whole number, without a decimal part. The modulus operator is written with the % sign and represents the remainder after floor division. Along with arithmetic operators come abbreviations for easier operator writing. Let's try numerical operators in practice. For greater clarity, Python provides us with a useful tool. When writing a number, we can use the underscore character at any time. This character is ignored when the program runs, but we can use it, for example, to separate thousands in numbers. We created 6 different number objects and assigned values to them. As can be seen when using the type function, Python has correctly distinguished which numbers are of type integer and which are of type float. Common arithmetic operators work as expected. However, one feature of the Python language should be noted. Even if the result of the division is an integer, Python always returns a result that is of type float after the division operation. But let's explain the floor division mechanism. We will divide the number 26 by the number 5. The result of the division is 5.2. If we use the floor division operator, the interpreter returns the number 5. It cut off the decimal part. But after division there was a remainder. We can find this remainder with the modulus operator. As you can see, the interpreter returned the number 1. We can check the result with this expression, which is valid. As with all data objects, Python introduces methods for numbers as well. There are only a few of them and they are so insignificant that we will not deal with them. The last data object we will consider now is the Boolean type. The name is somewhat strange. It is derived from the name of the English mathematician George Boole, who is considered the founder of algebraic logic. The Boolean data type is used for logical evaluation of expressions. The value of an object can take on only one of the values, true or false. The Boolean data type is important when we need to make a decision. First, we evaluate whether a condition is met and, depending on the result, we can start or reject a process in the program. In order to logically evaluate an expression, we will need comparison operators. Operators work exactly the same as in other programming languages. They compare two operands and the result is true or false. Let's try it in practice. If we need to create a Boolean object directly without evaluating a logical expression, we can do so with a simple assignment operator. You need to be careful about the capitalization of the words true and false. Both expressions always start with a capital letter. A more common way to assign a logical value is by evaluating a logical expression. So let's try to test the Boolean on a simple example. We ask the interpreter if the number 5 is equal to the number 3. The entry looks strange. But remember the order of evaluating expressions from right to left. First, it is evaluated whether the digits are equal, then the result is assigned to the variable. If we validate the type of the object, the interpreter returns a Boolean. In the same way, we can try to evaluate whether the number 5 is greater than or equal to the number 3. The result is true. However, you need to be careful about the data types of the individual operands. If we compare the data types integer and float, the interpreter will perform the conversion automatically and the numbers 1 and 1.0 will be equal. But if we try to use a string instead of a number, the interpreter evaluates the expression as false. If we still need to perform such a comparison, we must first convert one data type to another. In this case, we can use, for example, the built-in function int. So that's all for today's episode. Good job! We learned how to work with expressions and explained several basic data types. In the next part, we will show how to manage the program and practice some of the acquired knowledge. If you like the Python series for beginners, don't forget to subscribe and I'd appreciate a like too. I look forward to seeing you in the next episode.